Hi to everyone, and thanks for inviting me to present what we believe in Cisco is going to be our approach, our vision and strategy in terms of software-defined networks technology. My talk is going to be probably more oriented to a pragmatical vision of the SDN technology set. We come from the experience, obviously, of delivering routing architectures, network architectures, and technologies and implementations on service providers, for service providers. And so we started from there, and we built up what new services require. And SDN is a very good match for addressing those new requirements. However, we don't see SDN technology in a disruptive fashion. So we don't believe that SDN is going to wipe out whatever has been done before and reinstall a complete new vision of what a network infrastructure should be. So we are probably going to, and try to explain this on the next slides, we're going to see that we see SDN as an introduction of an additional technology to what exists today, so to better leverage all the richness that we have in network infrastructures. And we started this by very simple use cases towards more complex use cases, but we've immediately received an excellent feedback from the very simple use cases that we started to address. So it's very promising. I think the conclusion I'm going to make at the end of the presentation matches what Jennifer has explained on her presentation about the SDN plus openflow. Again, I will come back to what openflow can play in our approach. And but it's probably the path that we take that is slightly different. So what we did quite efficiently, I believe, in the last, 20, 30 years, maybe more, is to deliver network services and having very good infrastructures in terms of service providers. The scaling of the internet demonstrated that, well, it scales, it works. And today we are facing new challenges because applications cannot continuously consider the network as an infinite resource that is infinite at any time at no cost. So clearly applications need to have a better view of what is underneath, so what is in the network infrastructure. And at one side, what we want to do is to retrieve the information from the network, so what we call here the big data, retrieve this information, so to bring it up to the what's so-called the orchestration layers, or where you will have multiple orchestration elements, so to being able at one side to optimize your infrastructure based on whatever application requirements, and I will give you a couple of examples. But also what is in the marketing world called the monetization, so to be able to implement new services that leverage what the network can give you as an information and as a service. So we want to close the loop here. Bringing information out of the network, use it for optimizing and introducing new services, and bringing back state to the network. And probably this last step is the most challenging and innovative one, because this is what SDN is about. But do not underestimate this part. Bringing information out from the network and expose it to application. It's also where big challenges need to be addressed. And we have some technology. We have also well-known API that we can leverage to do this, but we also need, I would say, a few amount of extensions or new APIs, so to complete
the visibility of the network. If you think, for example, what if I want to retrieve from the network the topology of my infrastructure? Well, the topology is carried by link state protocols such as ISIS or SPF. So here we have a good example of well-known APIs that can be used to retrieve this information. But you know, if you're familiar with link state routing, that the visibility you can have if you're a router in an ISIS or SPF domain is limited to the area where you are. So what is the router you're going to use to retrieve this information? You will need more than one, so you will need, at some point, you will have to do some correlation with the information you bring up. Then you can use BGP to retrieve your VPN information or just your v4, v6 reachability and autonomous system path information. So you have well-known protocols, well-known APIs that can be leveraged today to retrieve information from the network. We are also working at some extensions to this. One very basic requirement that we got from a few service providers is in the IP layer, so in the OSPF or ISIS database, I just see neighbors. So routers establish adjacencies, and they see each other directly connected, while obviously we know that there is a transport layer underneath that doesn't, for sure, represents a direct connection between routers. So what if I want to know exactly what's underneath, or at least what if I want to know some of the information that will give me a clue of what is underneath. So those mechanisms needs to be defined, and for some of them even obviously implemented. Now, just a few words of openflow, at least from my perspective, so the perspective of the set of technologies that we have in SDN applied to service providers' networks. So openflow essentially is a matter of separating control from forwarding, which is a good thing. It brings a lot of advantages. However, in our case here, it's not only about control and forwarding. There is plenty of other layers that we have to take into account, starting from the optical transport, as I said before, and going up to services, operations, and management. So we need to take into account all the layers that sits in the service provider infrastructure. Now, we're going to see that the tools that we may want to use to cope and to use for first extracting information from a multi-layer infrastructure and also to set state in a multi-layer infrastructure, well, we may have the capability of using the same set of tools, so we don't have to reinvent the wheel at each layer, because that would be probably too complex. And again, what we want to do is two things. At one side, we want to collect, harvest all the network intelligence. We know that there is a lot of information in the network that would benefit to applications. Well, we want to collect all this. We partially have some tools. We are extending some other, some existing APIs. If you think about BGP, there is a proposal of extending BGP so to carry topology information. Well, this is very easily applicable to a multi-layer environment. And also we want to be able then to inject state, new state, update state into the network based on whatever orchestration layer that would take into account policies, application-specific requirements, and so on. So we used to say we have the whole information. We don't need to define new information, new sources of information. We know where to grab this information from, but we don't have anything that would allow today in a multi-layer environment to retrieve information from the network, so to globalize, aggregate it, virtualize, slice it, and so on. And here we immediately come to the point where we see the advantages, obviously, of what has been deployed in the last 30 years. Distributed systems, routing protocols. I don't believe, and I don't see very soon, a service provider get rid of ISIS or SPF or even BGP just because he will just program individually every single router in the network. It may happen one day, but I think it's not going to be easy, and it may not bring only benefits. So there are tasks that are very well addressed by distributed mechanisms, distributed paradigms like routing protocols, self-healing, rerouting, loop-free convergence, fast reroutes. So all those mechanisms are very well addressed by distributed technology, so it will work, and it will continue to work. However, there are other cases where the distribution model has some limits. What if you want to aggregate the information coming from a multi-layer network? Well, you cannot ask every single router in the network to be aware about all the stacks that you have in the network, knowing also that you have limitation on the visibility that each router, each switch has about the infrastructure, depending on the location where it is. And so we come here to the point where we have to think about some form of centralization on top of a distributed system. And this is what, for us, the SDN set of technologies are applied to a service provider network. So I will explain in the next slide what we consider one option that we consider for the SDN implementation on service provider. And the fact that we centralize some information doesn't mean that we remove dynamicity from the network. The network remains dynamic as it is today. Also is the definition of APIs protocols, northbound from the network, southbound into the network. So this is obviously part of the picture. Two use cases here. And just to illustrate the use cases, one of the two is implemented, deployed, and operated daily by a few service providers. It concerns content distribution. Content distribution optimized through mechanisms that leverage the infrastructure information and gives it in a useful fashion to the application, to the CDN. So I'll try to go through the whole animation. So the idea here is that a content provider that has to distribute content usually doesn't know anything about the infrastructure underneath. So the first very simple use case that we address is exactly this one. Let's the infrastructure to instruct, to guide the CDN about the topology. For example, what if I can tell the CDN what is the location of the user and what is the distance between the user and the closest cache, the closest streamer? What if I can instruct the CDN and the service provider to understand what is the best peering link to use for distributing content? What if I can set as a CDN the amount of resources I will ask to the service provider so to distribute my content? For example, I'm on a CDN and suddenly a user requests a video on a high definition quality. Well, I don't know if the user first has the ability from his connectivity point of view to receive this content. Someone has to tell me this. And I was talking with a mobile service provider who has another request from his CDN provider, his content provider, saying that when a mobile user asks for a content, he may exceed the quota that he has on his subscription profile. The CDN wants to know this because the CDN may want to pay for his quota that has exceeded, but prefers to deliver the content anyway. So those are a small example where clearly you need some communication between infrastructure and an application. So for the best benefit of both parties, the infrastructure and the content or the application provider. still in the same range, I'd say, is what we call the network weather report. So the ability of query the state of the network and retrieve from the network the information that I need, that a CDN may need to optimize its own business, its own distribution mechanism, or an application that wants to verify that the SLAs that are currently delivered to customer are still maintained, or are still satisfied. Well, again, here the service provider will maintain the ability for the application to send queries, to send requests into the infrastructure and to retrieve the information based on whatever criteria. And here, the service provider, what it needs a system, a component, an element, whatever, that is obviously under full control of the service provider and that has multiple capabilities. One of those is extract the information that I need. One other capability is aggregate this information for the application that is going to ask me this information. And also another capability is virtualize this information. As a service provider, I will probably not want to tell too many details about my topology, my infrastructure, if the application that asks me this information is a peer-to-peer community, because I may not trust them completely blindly. However, I may want to give more details about my topology and the state of my resources in the network if the application that asks me this is my own CDN, is the CDN that the service provider operates. So we need to be able to virtualize, to create virtual representations of a multi-layer infrastructure of a service provider. And this is what the weather report is all about. And again, here we have already an implementation which is used and gives a lot of benefits, because it's really encouraging and amazing to see that answering very simple questions from an application to an infrastructure perspective may already give a lot of improvement. Already for an application, already figured out the distance, the topology distance, or the topology infrastructure cost between endpoints is already a very valuable information from an application perspective. So here this picture aimed to provide you the end-to-end vision of what SDN would do in a service provider environment. Here is, well, all the information we can gather from the network. So whatever, from the core, from the access, from the mobile, from the fiber, the optical transport, up to the IP, topology, BGP, configurations, policies, and so on. And here in the middle, you have the multiple orchestration layers that will be able to collect, process, and pre-digest the information that needs to be delivered at the top, so to applications. This is probably something that I can skip. Here is to illustrate the amount of variables you have in this equation. So it's not something that is monolithic. You cannot define the component and say, okay, I collect this information, I do this processing, I obtain those data sets, and this is what I'm going to use. Well, it's really a moving target. It's really something that will follow the requirements that will be expressed use case by use cases. We have a variety of different applications over there. And you need to build up a set of technology which will be flexible enough to be extended without major rework, so to cope with those new and emerging requirements. So what is the shovel? So after stating that the network is very rich in terms of information, but we have no tools to bring this information up, well, our approach is based to an implementation that we already have, that has been defined a few years ago in the framework of MPLS traffic engineering, which is called the PCE, the Path Computation Element. It's already implemented, it's already deployed, where you have a server that today runs on a router, And the server, what it does, it computes traffic engineering path and tell the client who requested the path how to, what is the path so he can signal in. So the idea here is exactly the same. Take a server, extract it from the router, and make it run in whatever environment you want. And feed the server with the infrastructure information on a multi-layer environment. So from optical transport topology, IP topology, BGP reachability information, VPNs, configurations, policies, whatever. Feed this server. Implement in this server those building blocks, which are the different orchestration elements. And on top of this, or left and right of this, put those APIs that will allow applications to query the PCE, the SDN component, so to retrieve information, set, request state from the network. Why PCE? Well, PCE is a very good start because it has already all the foundation of the basic characteristics of what we need. It is already sitting in the infrastructure. It is already extracted from the network. It doesn't need to run on a box or another box. So it doesn't need to run in a router. It doesn't need to run on a server. It can run whatever in whatever incarnation you would prefer. So it doesn't have constraint from an operational perspective. He already has APIs that are used to collect infrastructure information, topology information. It's already it's something that is already well known, well established. We know how to do it. So we need to extend the implementations so to cope with the multi-layer environment, so to be able to do the same thing at each layer: collect, process, store, pre-digest, deliver to application. So it seems a very natural approach for using PCS, PCE technology. Oh, this is duplication. So here is to illustrate the multi-layer components here. So here, if you have a multi-layer PCE, you can see the different layers. So here I take 3 examples. One is the optical transport. This is the IP MPLS, and this is the more the service topologies. So how services are chained one to the other. The interesting approach here is in terms of APIs. What do we have here? Well, in fact, you will see the same set of APIs. Again, let's not try to reinvent the wheel to solve the same problem in another space. So if something works in one layer, there is no reason why it couldn't work for another layer. We talk about topology, we talk about attributes. What we want is to retrieve the topology and retrieve the attributes that are part of the topology, and this on every layer. So let's extend what we already have, and we started the work with BGPLS in ATF with this extension that allows to propagate topology information into BGP. Obviously, we're not talking about replacing OSPF with BGP, so it's just an extension for transporting other information than just IP prefixes. PSAP. PSAP is a protocol that is already used in traffic engineering for signaling path. Well, signaling path works. It has been very recently extended after a proposal from Google and Juniper and Cisco on the stateful capability of PCE. And I will now talk about what are the challenges behind this. But clearly, it's a protocol that will work pretty well in this context. So let's reuse the same set of APIs in the multi-layer infrastructure so to retrieve, to harvest the complete view of the infrastructure. One point here is the slicing, the virtualization. As I said before, you have to give the capability to the service provider to tailor, to customize the information he wants to deliver to applications, to the upper layer. So this is critical, this is vital. You cannot deliver blindly everything to everyone. So you have to be able to define mechanism to control this. Now, one of the challenges that seems not to be very well addressed yet, but we are coming to this, is the following. When you have a completely distributed model as we have in computer networks today, in the internet today, there are cases that you don't have to cope with, which is synchronization. Each router is capable of handling his business alone. It will reroute based on the information about OSPF or ASIS. It will set up tunnels based on the RSVP signaling it will receive, and everything is fine. Now we introduce some level of centralization. So conceptually, this means you put a server somewhere in the network that will concentrate some of the information, process it, and make some good use of it. And this server will also be responsible at some point to inject state into the network, and so to modify the state of the network. And so the server becomes a critical part of the operation of the network itself, because there is a difference between I extract topology and I tell you something about the network, and the ability to say, ask me something and I will modify the state of the network for you, because then it means that you have to maintain this state. It means that you have to be able to change, to update this state at very fast speeds just to cope with fast convergence issues, loop preventions, and so on. So this introduces another problem, is state synchronization, because you don't want a single server in the network, because if it crashes, you really have a serious problem. So what you want to have is multiple servers that will collect the information from the network, process it, deliver it, and eventually introduce state in the network. But then it means that each of those will have to be fully aware about the state introduced by the others. So this introduces new mechanisms. Well, new mechanisms. We have to think about mechanisms so to make those servers to be fully synchronized and fully reliable at any time. So in fact, what we see here is that the requirements that we have in the infrastructure are not vanished. We're not vanishing, because the same requirements are going to be replicated at the SDN layer when you will have multiple servers cooperating on top of the infrastructure. So we have to take this into account. Today, there is little that is being done in this space, and it is something that is going to be very critical in the future. So I don't know if I'm still on time. Yeah. So, and this is the conclusion. So what we can say is we're putting a lot of effort in SDN because we believe it's a set of technologies that open a lot of opportunities, and especially it allows a service provider to really start leveraging his infrastructure for building new services and to optimize existing services. So this is clearly a space where Cisco is investing a lot. We are in the phase of defining architecture, exploring maybe ideas, but at the other side, we're also working on implementations. We have components of the SDN architecture that are being implemented, and some of them are already implemented, and for even some of them are deployed and operated every day. So it's clearly a direction that we are taking seriously. As regard of openflow, well, it's certainly a component of the SDN architecture, but it's a protocol. So SDN is much more than just protocols. We are going to support, obviously, openflow. Today, openflow is it's a work in progress, so there are still a few things to do. We are also working on an implementation of openflow. So we're not questioning this, but we believe that SDN is way more than just one API instead of another API. It's a matter of the whole architecture. Also, SDN, I don't believe is going to be disruptive in the sense that it's something that will be gradually introduced in service provider networks on top of existing infrastructure. It's something that will add value to the service provider. So it's not something that will require the service provider to radically change completely the way he engineers and operates networks. But it's certainly something that will keep us busy for the next years, which is at some point a very good thing. So I hope to have covered exhaustively the argument. I mean, the Cisco position on SDN. Obviously, we have to keep in mind the overall picture. When we think about SDN, we have to think about everything that we have out there. It's not just a matter of optimizing the way optical transport talks to IP and PLS layer. No, there is way more than that. There is all the intelligence that you have at the access aggregation layer. We didn't talk about mobility and so on, but all the user information, connectivity information, profiling, telemetry that you have in the access. So you need to take this into account at one side, and at the other side, all the interaction with data centers environment and applications environment. So it's a broad subject. It's a wide, very wide set of technologies, and the architecture has to take into consideration the ability, obviously, of being extensible and easily, obviously, to engineer and operate. So those are the main challenges that we're going to be faced to. And this concludes my presentation. Thank you.